Okay, hi guys, welcome back to Think Tank Online Learning. So in this video, we're going to talk about line integrals. Okay, so first of all, we're going to talk about line integrals along a vector field in which you're not given the path to follow. Okay, after that, we'll do some more and some more. Okay, I hope you've subscribed to my channel. Okay, so if you like video, just show me by commenting and by liking. Okay, so first of all, given a problem, we're given a vector field, okay, and want to evaluate the line integral from the point 0, 0 to point 1, 1 along a straight line. Okay, so what we're going to do, I'm going to say this point is point 0, 0 is point A. Okay, so point 0, 0, 0, 0, 0 is point A, and B is equal to point 1, 1, 1. Okay, so now I want to find, let's say, the equation of a line in terms of vector. So I'm going to have RT, okay, is equals to A plus T AB. Okay, and you know that AB is equal to B minus A. Okay, in other way, I want to form a parametric equation in form of T. Okay, so what I'm going to have here, I'm going to have RTA, which is the point I'm starting 0, 0, 0, okay, to T. Okay, then AB said it is equals to B minus A, so I'm going to have 1 minus, I'm going to have 1 minus, I'm going to have 1. Okay, so now that's what we're going to do. This is the value for X, Y, and Z. So from now, I think it is now clear that X equals to 1, 0 plus 1T, that is equals to T. Okay, and Y is equals to T, and Z is equals to T. Okay, and the interval for T, or the limits for T, okay, T ranges from 0 to 1. Okay, it only changes when there's an angle. Okay, so now in order to perform this line integral, okay, we have this vector field. Okay, so we want f dr. Okay, so now I stands for dr, dy, dx, then j stands for dy, and k is for dz. Okay, so we can find dz using these equations. Okay, so let's try to find dz. Okay, so now dz, dx, and y. Okay, so from the first equation we can say that dx dt is equals to 1. So this means dx is equal to dt. Okay, now for the second one, dy dt is equals to 1. So that means dy equals to dt. And for this one, that means dz dt is equals to 1. So that means we're just making z dz dy dx with the formula A. That means dz is equals to dt. Okay, so now let's perform our line integral. Okay, so we said t ranges from 0 to 1. Okay, so if t ranges from 0 to 1, okay, we have 3x here, but we know that what is the value of x? The value of x is t, so we have 3t squared, okay, plus 6. Okay, so it's 6t. Okay, we have 6t here. What about for I? Okay, I said I is dx, so I'm just going to get dt. Okay, then we have plus, okay, actually it's negative 14 for t. We're going to have t, y, and z is also equal to t, so we're going to have times t. Then for j, which is dy, and let's say dy is equal to dt, plus we're going to z, we have 20, and x is t. Okay, then we have z is t squared. Okay, and we have dt, and now I want to integrate here 0, 1. So if we just simplify, we're going to have 3t squared, and we're going to factor out dt. Okay, since we have dt here and dt here, so we're going to have 3t squared plus 6t. Okay, and we have negative 14t squared. Okay, and here we have plus 20 t to the power 3 dt. Okay, and what are we going to get? Okay, so if we integrate, we're going to get 3t to the power 3 over 3 3t to the power 3 over t plus 6t squared over 2, okay, minus 14t to the power 3 over 3, okay, plus 20t to the power 4 over 4, our interval 0 to 1, okay. And what are we going to get? We're going to get, okay, so this one will cancel. Here you're going to get 5, okay, and you're going to get 3, okay. So in other ways, we have 1 minus 3, 1 plus 3, okay, minus 14 over 3 plus 5, okay. And what is the answer here? Okay, so we're going to get 1 plus 3 minus 14 remainder 3 plus 5, okay, and we have our answer is equal to 13 over 3, okay. So now we're going to part B. Okay, so on the second part, okay, we're given that along x equals to t, okay. So this is, it's not hard, okay, it's still simple, okay. So for this part, look, okay, I think they just keep this stage, and we're now at this stage, okay. We say the interval for t is from 0 to 1, okay. So we're going to start here, okay. So you see, we have, what do we have? We have x equals to t, okay. So x is equals to t, that means dx dt is equals to 1, and that means dx is equals to dt, okay. And now y equals to t squared, that means dy dt is equals to 2t, and this means that dy is equals to 2t dt, okay. And we're going to do that for z equals to t cubed. So now we're going to have dz dt equals to, now we have dz dt equals to 3t cubed. So this means dz equals to 3t squared dt, okay. So now what we're going to do, we're using our vector field, okay. So we're going to say, and you have to know that this is not a closed path, okay. Both are just going, we're not returning back, okay. So we're going to say ftr, okay, the interval for t 0 to 1, okay. So we have 3x squared and x equals to t, so we're going to have 3t squared plus 6y. What is y? Y equals to t squared, so that is 6t squared. And for d, for I, which is dx, we say dx is equals to dt, okay. And now we have negative 14. What is y? Y is t squared and z equals t cubed, so we're going to have t to the power 5 times what is dy, so dy is 2t dt, okay, plus 20, okay. We have x times z cubed, so since z equals t to the power 3, that we're going to get t to the power 6 times another t, and what we're going to have, t to the power 7. And what about dz? Okay, as you can see, dz is 3t squared dt, okay. And now I want to factor out t, okay. So let's factor out t and perform our line integral. So we're going to have 0 to 1, okay. And we're going to have, if we add here, we're going to get 9t squared, okay. And what about here? We have 14 times 2, then we're going to get negative 28. T to the power 5 times t, that is t to the power 6, okay. And we have t 20 times 3, so we're going to have 60, okay. T to the power 7 times t to the power 2, we're going to give t to the power 9, and we have dt. And now it's time for us to integrate 9t cubed over 3 negative 28 t to the power 7 over 7, and we have 60 t to the power 10 over 10. Our interval from 0 to 1. Okay, so if we integrate here, we're going to see that 3 into 3, we're going to get 1. 3 into 9, we're going to get 3. Okay, then 7, 7 here, we're going to get 4. Then here, okay, see, we're going to get 6. Okay, so that means we have 3 minus 4 plus 6. And what is the answer? The answer is equal to 5. Okay, so now we're moving to the next stage. Okay, want to find the work done on joining this line to this point to this point. Okay, okay, so for this part, okay, see, we got a straight line joining this point, and this point. Okay, so if we say, let's say this point 0 0, let's say point 0 0 is equal to a, so say a is equal to 0 0. Okay, b is equal to 1 0 0. Okay, and we have c, which is equal to 1 1 0. Okay, so what is going to be our path? Okay, so our path will go from a to b. Okay, then from b to c. Okay, I think you need to master this because it is going to help you when you evaluate your Stokes theorem. Okay, so now we're going to find the parametric equation from a to b. Okay, so from a to b, I want to find that vector. Okay, so from a to b, you're going to say rt is equal to 0 0 0 plus t ba ab, which is b minus a, and we're going to have 1 0 0. Okay, so that means what is going to be x is going to be equal to t, y is equal to 0, then z is equal to 0. Okay, so if y equals to 0, that means dy is equals to 0. If z equals to 0, dz is also equals to 0, but dx is equal to dt. Okay, and we're still using our vector field. Okay, so now look at our vector field. You said t, the interval for t is still from 0 to 1. Okay, as long as it's not an angle. Okay, so now this is going to be our line integral from 0 to 1. Okay, so we have 3x squared. Okay, 3x squared, so that means we have 3t squared. Okay, then for y it's 0. Okay, then for dx is dt. Okay, look here, we said j, which is dy, is equals to 0, then z, which is d, which we have k, which is dz, and it's equals to 0. So I'm just going to integrate this, and what are we going to get? We're going to get 3t to the power 3 over 3, and we're going to get the answer 3. Okay, but or from here to here, so that I think I should have written the formula for finding the work done along different points. Okay, so I'm going to say f dot dr c is equals to f dot dr for c1 from this point, okay, plus the integral of c2 now to this point, okay, like this. Okay, then now we have c1 here, so this was c1. Okay, so this was for c1. Okay, I could just write c1 here. Okay, now going to c2. Okay, so for c2, our parametric equations, okay, so our parametric equations are t, okay, okay, it's going to be the initial point, which is 1 0 0, okay, plus t, so I'm going to say c minus a. So for x, 1 minus 1 0, for y 1 0. Okay, so this means, what does this mean? X is equals to 0, y is equals to 1, and z is equals to 0. Okay, like this. Okay, so that if x equals to 0, dx is equals to 0. Then if y equals to 1, y equals to 1, so that means we have got dy. Okay, actually y is equals to t. Okay, so that means dy is equals to dt. then here is equals to 0, so dz is equals to 0. Okay, so now let's evaluate our line integral for c2. Okay, interval for t 0 to 1. Okay, then we have 3x squared. X is 0, but y is not 0, but we know that dx is equal to 0, so we're going to have nothing here, and here c is equals to 0. Okay, and we're going to have nothing here, and here we're going to have nothing, so we're just going to get 0 dy. Okay, so it's not 0 dy, it's now 0 dt. Okay, so if you integrate 0, you're going to get 0 t. Okay, but if you don't have anything, let's say we have 1, we're going to have t, but if you have 0, we're going to get 0. Okay, so that means the line integral, I'm going to say f dr for c, it's going to be f dot dr for c1 plus f dot dr for c2, and this is equal to 3 plus 0, and we're going to have 3. Okay, so 3 is our total answer. Okay, and now we're moving to the next question. Okay, so this is the basic. Now going to the one which is more advanced. Okay, so this is the question we're now looking at. Okay, so the difference between the first question and this question is that we're not given a vector field, but we're given a path to follow in this question. Okay, so this graph is from -1 0 to 1 2. Okay, and we are seeing wave y equals to x squared plus 1. So if we were to graph this graph, we're going to draw the graph of y equals to x squared, and we're going to shift it. Okay, it is going to move one step on the negative side of x. Okay, so what we're going to do here is that you choose what you want. Okay, so given that y is equals to x squared plus x. Okay, so what we're going to do, we're going to choose base parametric equations. In this case, we don't need t. Okay, so in this case we don't need t. So what do we need? Okay, we're given that y is equals to x squared plus 1. Okay, so since y equals to x squared plus 1, we can say x is equals to x. Okay, but instead of writing y, we can write x squared plus 1. Okay, so this is equals to y. Okay, so that means now I think we have, it's just more like a substitution. Okay, so that means dx is equals to dx. Okay, so what about dy dx? So dy dx is equals to 2x. Okay, so if we make the wasabi with the formula, we're going to get this is equal to 2x dx. Okay, so now since we choose x to be our parameter, we have our lower bound for x is from this point -1 to 1. Okay, so now I'm going to write, this is going to be our integral. Okay, so I'm going to say f gr is going to be our lower bound for x, so considering x, since x is our parameter, -1 to 1. Okay, and we have 6 for x, we're going to write x squared, but for y we're going to write x squared plus 1 dx. Okay, and we're going to get plus 6, but for y, what are we going to write? For y, we're going to write x squared plus 1, because we're choosing x to be our parameter, and dy we're going to write 2x dx. Okay, so this is what we want to integrate this one. Okay, so let's first expand. Okay, so if we're given limits like this, I think I can just say 2 0 to 1. Okay, so now we're going to get 6x to the power 4, okay, plus 6x squared. Okay, and I think we should factor out the x. Okay, and we have 2x times x, that is 2x squared, times 2x times x squared. So we're going to get 2x to the power 4, and we have 2x squared times 1, so we're going to have plus 2x squared dx. Okay, so now we have like terms, this one and this one. I think we're going to get 8x to the power 4. This one, we're going to get 8x squared dx. Okay, And what are we going to get? We can factor out 8. Okay, so we have 2 times 8 on the outside, 0 to 1. Okay, and we have x to the power 4 plus x to the power 2 dx. Now let us integrate. So we have 2 times 8. Okay, so we're going to have x to the power 5 over 5 plus x to the power 2 over 2. And we have our limits 1 and 0. And what are we going to get? We're going to get 16. Okay, then we are going to get 1 over 5. Okay, plus 1. Okay, if we integrate here, we're going to get x to the power 3 over 3. Okay, it's x to the power 3 over 3 plus 1/3. Okay, so if we say 1/5 plus 1/3 times 16. Okay, so our answer is going to be 128 over 15, if I didn't make any mistake here. Okay, so now we're going to another different question. Okay, we're given, let's say, along a circle. So what do we do? Okay, so now we're going to that question. Okay, so this is our question. Okay, so given a vector field and want to find the work done on the vector field, if the contour is the portion of a circle, x squared plus y squared is equals to 1 from this point to this point. Okay, and you should note that we're in space since we're given these coordinates. Okay, so let me just write them in. Okay, so I'm going to say coordinates for a. Okay, a, we have 1 0 3, and b we have negative 1 0 3. Okay, so now I think if we were to sketch this graph, we're going to see this is going to be a same circle. Okay, because we have something like this. Let's draw it in the xy plane. Okay, we're just trying to get a clue in the xy plane. Y x. Okay, so this circle has got a radius of 1, and as you can see, we're at 1 x equals to 1, x equals to 1 a, and go to x equals to negative 1. Okay, and remember our path is anti-clockwise, so we're talking about something that looks like this. Okay, so now we want to choose our parameter. Okay, but note that if we want to let's say if you want to make sense of the formula, we have square root, and no, it's not easy to integrate something that is inside the square root. So let's think of something. Okay, this is a circle. Okay, or it's a cylinder if you want space. Okay, so what are we going to say? What if we say x? What is x? We know that x in polar coordinates, x is equal to r cos theta. Okay, and r is what? R is radius. Okay, instead of saying theta, let me just choose t. Okay, or let me just choose r cos a. Let me just choose t. So we're going to have r cos t. And what is y? Y equals r sine t. But z doesn't change. Z is equals to z. Okay, and we have the radius. Okay, so this one x is equals to cos t, since the radius is 1. Y equals to sine t, and z is equals to z. Okay, so now what are we going to have here? Okay, we know that our t, you see, t is now a circle. It's now a same circle. Okay, so what is the interval for t? Okay, it's from 0 to pi. Okay, so now we're not told whether we're going anti-clockwise or a clockwise direction, but you should know that we're going the anti-clockwise direction. So let's say if you've drawn a graph like this, a curve like this, okay, you are going to have a problem, especially in evaluating the upper and lower bound of your parameter. Okay, so now we'll say that from the anti-clockwise direction, in this direction. Okay, and so what are we going to do? We're going to say the integral. We're going to say cf dot gr is going to 0 to pi for t, and we have x squared plus y squared. Okay, so this is going to be cos squared t plus sine squared t, okay, times I. That is what? Okay, and you should know that we're just moving here. We don't need I. Okay, so we said I is dx, and j is what? J is dt, j is dy. Okay, so let me just write here dx minus 2 cos t sine t dy, okay, plus 2, what is k? Okay, so we see that what is the value of k, which is z. The value of z is 3. Okay, so I'm going to have 3 cos t dz. Okay, but you don't need this since you know our parameter is t and we have dx. Okay, so what are we going to do? Let's differentiate our parameter here. Okay, our formulas. So if we say dx dt, if we differentiate cos x, I think we're going to get negative sine t. Okay, so that means dx is equals to negative sine t dt. Okay, and we have, if we differentiate dy dt, we're going to get cos t. Okay, and if we make dy side of the formula, we're going to get dy is equals to cos t dt. Okay, then for z, if we differentiate z with respect to theta, I think we're going to get 0. Okay, so f dz is equals to 0. Okay, so now let's go from 0 to pi cos square theta times sin square theta, that is equal to 1. Okay, and the dx is equal to negative sine t, okay, dt. And here we have negative 2. Okay, I think it's negative 2 cos t sine t. And for dy, what do we have for dy? For dy, we have dy equals to cos t dt. And here I don't want to waste my time writing here because know that dc is equals to 0. Okay, so now I can write this is now for dt. So if you factor out dt, you're going to have 0 pi. Okay, so in order to avoid confusion, I'm going to factor out negative. Okay, so I'm going to be left with sine t plus 2 cos squared t sine t dt. Okay, and want to integrate here. Okay, so I'm going to integrate this separately and this separately. Okay, so first of all, if you integrate sine, we're going to get negative cos. Okay, so we're going to have negative 0 to pi of sine t minus negative 0 to pi of 2 cos squared t sine t dt. Okay, dt. So if we integrate sine t, we're going to have negative cos t, and if we multiply that by negative, we're going to have positive. Okay, so we're going to have a positive cos t in interval from 0 to pi. Okay, plus, okay, then for a, I think I should not be doing this, but I'm just doing it. I'm going to use substitution, but if you're not familiar with what I'm doing, with what I am going to do here, you can just check on one of my videos. You can just go to the thinktankonline learning playlist Mulitivariable calculus. Okay, so here I'm going to, first of all, let me just put this negative before I forget. Okay, so now if I want to integrate 2 cos squared, okay, let me just factor out 2 again. Okay, so now I want to integrate cos squared t sine t. Okay, you choose the one with the bigger power. Okay, so the one with the bigger power is cos, so I'm going to say let u be equal to cos t. Okay, now we're going to differentiate du dt equals to negative sine t. Okay, making du side with the making dt side with the formula, going to get dt equals to negative du sine t. Okay, and if we do that, what are we going to get? We're going to get, I'm not going to change my limits. Okay, so we have 0 to pi. Okay, and we have u squared sine t. Instead of writing dt, I'm going to write du, but we have a negative, so I'm going to put a negative over sine t. See, this one and this one cancel, and what are we going to have? Going to have u to the power 3 over 3. Okay, we have a negative, our interval from 0 to pi. Okay, so we know that u is equals to cos theta, so it's like saying negative cos cubed t over cos cubed t over 3. Okay, so I think this is what I'm supposed to write here. We got 2. Okay, so I'm going to write 2 cos cubed t over 3. Our limit 0 to, okay, it's 0 to pi here, 0 to pi. Okay, and what is going to be our answer? Okay, then if we simplify here, okay, remember we're going to say 2 times minus 2 times, okay, we're going to get negative 10 divided by 3. That is going to be the work done on this line integral. Okay, now we're going to the next question, which is a more advanced like this one. Okay, so this is another question, but this case we have a closed path. Okay, so I think you should just master this because you're going to use this information especially in verifying Stokes theorem. Okay, so now this thing is in the first octant. Okay, and we're given that the equation of the plane is, okay, so I've tried to draw. Okay, so in the xy plane c equals to 0, so we have x plus y equals to 1. Okay, then in the xz plane y equals to 0, we have x plus equals to 1, just like in the xy plane. So now I want to find the line integral instead of a closed path. Okay, so let me call this point A. Okay, I'm going to call this point A and call this one B and call this one point number C. Okay, so now the line integral f dr is not a closed path. Okay, it's going to be the integral, okay, f dr c1, okay, I don't think, maybe, okay, from A to B plus the integral f dr c2 from B to C plus f dr c3 from C back to A. That is a closed path. Okay, so I'm going to just do what we have just done there. Okay, so first of all, from A to B, okay, let me just list the points here. From A to B, we have these equations xy. Okay, so we have xy. So let's just try to make x of the formula. Okay, so if you make x of the formula, we're going to get x equals to 1 minus y. Okay, here you see that is what we're going to get. Okay, so that means if we say y equals to y, that means y is equals to y, and then the base c z is equals to 0. So we're going to use our parametric. Our y is our parameter. Okay, and remember that y here, y is 0, and here y is 1. Okay, so now what is dx dy? Dx dy is negative 1, so that means dx equals to negative dy. Okay, and here dy dz equals to 0 dy. Okay, so now let's perform our line integral for c1. Okay, so c1 here, you can say f dot dr. I'm going to say y is gaining, here was 0, and now y is now 1. Okay, so if you look at our vector field, we have 2yx, okay, z, but here z is 0, so we don't need z. This is going to be 0. What about here? Here we have x. What is x? Okay, so now what is the value of x? X is 1 minus y, okay, plus 3y, okay, minus 2, and for j is dy. Okay, then dz equals to 0, so I'm going to just integrate this simple thing. 0, 1. Okay, so if we simplify here, we're going to get 1. Okay, negative 1 minus 2, I think that was supposed to be negative 1. Negative 1y plus 3y plus 2y dy. And if we integrate, we're going to get negative y plus y squared, 2y squared over 2. Okay, 0, 1. And what is going to be the answer? Okay, so the answer is going to be negative 1 plus 1. And that answer is going to give us 0. Okay, for C1, okay, don't get shocked. Okay, it's possible. And now we're going to C2. Okay, so C2, I think in order to give you a clue, let me just say AB. Yeah? Okay, so for C2, I'm going to write C2 here. Okay, so C2 is BC. Okay, BCFDR is going to be. Okay, so now look, I have this equation. Okay, but I just love playing with y. Okay, so what I'm going to say is that what is z? Okay, so z is equals to 1 minus y. Okay, and what is y? Y equals to y. Okay, what about x? X here, x is 0. Okay, and we'll call that the blue line. Okay, this blue line, x equals to 0. Okay, then the z dy is going to be negative 1. So that means the z is equals to negative dy. Okay, and that means the x equals to 0 dy. Okay, so now we're going to integrate. Okay, so y was 1 here and y is now 0 here. So what we're going to get, we're going to say y from 1 to 0. Okay, I know if you point this in a calculator, it may say this expression can be integrated, but in line integral, that is what we do. Okay, so we have 2y c. Okay, I is dy is dx. Dx is 0, so we don't need this one. But what about a? Okay, we have negative. Okay, and now I'm starting to notice something. Okay, remember when we evaluated dy here, we did include the negative sign here, but it's not going to change the answer. It's just going to get 0. Okay, but I think the signs are going to be changed. We should have negative here and a plus here. Okay, so we should not make that mistake again. Okay, so we're going to have a negative 3. We have x. Okay, x is 0. Okay, plus 3y. Okay, minus 2. Okay, then for j is dy. Then for z, we have what is z plus 1 minus y. X is 0. Then for k, which is dz, what is dz is negative dy. Okay, so let's integrate here. Okay, so if we integrate, we're going to have 1 0. Okay, let's group for integrating. So we're going to have 2 minus 3y. Okay, negative 1 plus y dy. Okay, and what are we going to get? 1 0. Okay, so I'm going to have 1 minus 2y dy. And now integrating with respect to y, we're going to have y minus 2y squared over 2. Our bounds from 1 to 0. Okay, so if you say upper bound minus lower bound is 0 minus lower bound, we're going to have 1 minus 1 here. Okay, so 1 minus 1 is 0, so we're going to have 0. Okay, so for the last part, okay, which is the last line, okay, so this is going to be C3. Okay, just because we have 0 here, 0, that doesn't mean we have 0. We have to prove it. Okay, so we're going to say the path is CA. Okay, FDR. Okay, so what do we have? I think we should just master the concept of this topic. Okay, because we're going to need it in verifying Stokes theorem and everything. Okay, so I think I'll upload the video for verifying Stokes theorem of a tetrahedron, again the first quadrant. Okay, so just subscribe to stay tuned. Okay, so we have a equation of this line. Okay, so the equation of this line is x plus z equals to 1, and I think I want to make this a good formula, so I have 1 minus x. Okay, so that means x equals to x. I've chosen x to be my parameter, then y equals to 0. Okay, so dz dx here is going to be -1. That means dz equals to negative dx, and here if y equals 0, that means dy equals 0 dx. Okay, so now I want to set up our integral, line integral. Okay, x is 0 here, okay, and x is 1 here. Okay, so look for dx. Okay, we have a number, but y is 0, so I'm not going to need this. And this one, remember that dy is equals to 0, so we're not going to need this one. But for this one, we're going to say x squared, and know that c is equals to plus 1 minus x, okay, times what is the z? Negative dy. Okay, so that is going to be the negative of x squared plus 1 minus x dx. Okay, so now let's integrate respect to x. It's x to the power 3 over 3 plus x minus x over 2, x squared over 2. Then we find limits 0 to 1. Okay, so what are we going to have? What are we going to have here? Okay, since we have a negative, going to have negative 1/3. Okay, negative 1/3, negative 1 plus 1 remainder 2, and what is going to be the answer? Okay, negative 5 over 6. Okay, so what is going to be the answer? Okay, so the total line integral for the closed path is going to be 0 plus 0 minus 5 over 6, and that is equals to negative 5 over 6. Okay, thank you for watching. Don't forget to subscribe. Show love by liking, commenting. Okay.